Hey there everyone, so today I'm going to talk a little bit more about factoring. So if you watched the past two videos, you've probably got an introduction into factoring and how we factor quadratic equations. So in this video it's a little bit more into factoring, and I'm just going to mention a quick little trick that you can use for factoring certain polynomials, so quadratics I mean. So there are specific special cases, we call them, in quadratics where you can factor a little bit easier than the methods I've shown before, being the multiplying the sky, the complex factoring, and just finding two numbers. So there is an easier way of factoring these polynomials. So before I get started on that, I just want you to remind you of this form, the ax squared plus bx plus c. So just remember what the a is, what the b is, and what the c is. If you remember that, this video should be a little bit better for you guys to understand. So let me erase that and let me get to the first example I want to cover today. So the first example is x squared plus 6x plus 9. So if you look at this, you can probably go straight ahead, try to look for two numbers that multiply to 9 and add to 3. You can go ahead and do that, you probably already know those two, but what I'm here to show you is that you can go towards an easier way of finding these two factors. So what you have to do is you have to find the square root of the first number. So what's the square root of the first number? Well, that's just 1, or the square root of x squared, my bad, is x. So the square root of the x squared term, so that's just x. So that's one of your factors. And you have to find the square root of the constant, the c, right? As I showed before, the ax squared plus bx plus c, this is the c. So you have to find the square root of the c. So what's the square root of 9? Well, that's just 3. So the easiest way to do this is x plus 3 squared. So as you can see, this is called the perfect square trinomial. What this means is that the first number here, the x squared, it's a perfect square, right? X squared is a perfect square of x and x. And then the 9 on the end is a perfect square of 3 and 3, right? 3 times 3, you get 9. So rather than finding my two numbers that add to 6 and multiply to 9, I can just find the square of this, the square root of this, the square root of this, and just write it in my binomial and put the squared symbol. That's all there is to it. So I'll do a couple more examples, but there's something I need to highlight here. For this to work, you're like, well, this value right here probably has no meaning. We just need to find the square root of this and the square root of this, and then you just put it in and then write the square. Well, you would be wrong in thinking that, and I'll explain why. I used to have that way of thinking too. But the reason you're wrong in thinking that is this number here actually does play a role. Because for this factoring technique to work, you have to meet a certain set of conditions. So the conditions are the square root of a times the square root of c multiplied by 2 must equal b. So a lot of letters and a lot of numbers, but all this means is that the square root of this number, so the square root of x squared is just x, but we're talking about the coefficients here. So what's the coefficient in front of the x squared? Well, that's just a 1, right? We don't write that. So the square root of a, so the square root of a is just 1, right? And times the square root of c, so what's the square root of c? 9, square root of 9 is 3. Multiplied by 2 has to equal b. So what's b here? 6. So does that work here? So the square root of a was 1, times the square root of 3, which is the square root of c right here, was 3. And then multiplied by 2 equals 6. I apologize, I might have said square root of 3. That's not what I meant to say. I meant to say the square root of a, so 1 is a, so square root of a is 1, square root of c is 3, multiplied by 2 must equal b, and there I have it. 6 is b, and then it worked out. So let's do another example really quickly. Again, these are factoring techniques, so you can always go ahead and use the complex factoring technique where you find two numbers that multiply to the middle number, that add to the middle number, multiply to the outside number. You can always go ahead and do that, but there are techniques that make life a little bit faster. And in mathematics, we always want to do things as fast as possible, but as properly as possible, if you get what I mean there. So the next example is x squared plus 10x plus 25. Again, recognition is really important in these cases because you'll notice that x squared, hey, perfect square, 25, perfect square, works. So again, create my binomial here. So what's the square root of x squared? Well, that's x. And we look at c, well, what's the square root of 25? Well, that's 5. So x plus 5, and I just put my squared. That means there's two of these, right? Because plus 5 and plus 5 make the 10, and then 5 times 5 is 25. Anyways, don't worry about that. You square root this, you get x, you square root that, you get 5, put 2 brackets, and then write squared. That's all there is to factoring this. And now, we always have to check with this number. Remember, we can't just go ahead and do this without checking the middle. So again, let's do our little check. So what's our check? Well, the square root of a times the square root of c times 2 must equal b, right? So what's a in this equation? Well, a is 1, right? We don't see it, that's why a is 1. So square root of 1 is just 1, multiplied by the square root of c, which is 25. So what's the square root of c? Well, that's 5, multiplied by 2. So what's 1 times 5 times 2? Well, 1 just kind of cancels out. 5 times 2 is 10. And is that b? Yes, exactly, it is b. So it works perfectly. If you see a perfect square trinomial where the x squared term is a perfect square, and then the c is also a perfect square, the constant, you can go ahead and use this factoring technique called the perfect square trinomial technique, where you just take the square root of that, take the square root of this, and just put a square. That's all there is to it. But before you move on, always do this little check, where you take the square root of the coefficient of the x squared, take the square root of the constant, and then multiply by 2, and see if you get the middle term. This you don't even have to write down, you can kind of just do in your head, because of simple cases like this, right? The square root of that is just 1, square root of 25 is 5, so 1 times 5, times 2 is 10, 10 is there. Works perfectly. So let's do one more example, and then we'll call it a day for today. So let's take 16x squared minus 48x. So notice how there's a negative in the middle now? That does not change anything, except in the binomial I'll have a negative in there instead. That's all there is to it. And I'll show you what happens with the checking technique as well. So what's the square root of 16x squared? Well, the square root of 16x squared, well, before I say go on doing that, notice how my x squared term is a perfect square, right? 16x squared. 16 is a perfect square, x squared is a perfect square, so my x squared term is fine. 36 is also a perfect square. So it helps to know your squares. It doesn't take too long to memorize 1, 4, 9, 16, 25, 36, 49. Just go ahead and memorize that if you want. It'll just help with the recognition game in here. But always you can go with the common factor and go ahead and do that if you wish, but you don't have to. But anyways, let's go ahead and look at this. So you may have spotted a mistake I made. I went right ahead here and I started taking common factor. Well, I started taking the square roots and then I started using the perfect square trinomial technique. But notice how I forgot to do something important. I forgot to look for a common factor here. I didn't do that. So I should look first for a common factor. So what's the common factor for 16x squared minus 48x plus 36? Well, in my opinion, I think 4 divides evenly into all of this. So let's take 4 as my common factor, right? So 4. So 4 times 4x squared gives me 16x squared, right? So there's my first term. So what's 48 divided by 4? Well, that's 12. 12x. And what's 36 divided by 4? Well, that's just 9. Again, so first we took our common factor. I apologize, I forgot to take a common factor. I'm kind of in a rush to get this video out because I haven't uploaded in a few days. So I apologize for that, but here we go. We took our first common factor and now we have this to factor here, right? We have to factor this, 4 stays on the outside. So again, notice how my term here, my first term here, is a perfect square, 4x squared, right? 4 is a perfect square, x squared is a perfect square. Notice how 9 is a perfect square, right? 1, 4, 9. 9 is the perfect square of 3 times 3. So I'll have 4 on the outside, but to factor this, so I take the square root of 4x squared. Well, the square root of 4x squared is just 2x. And what's the square root of 9? Well, that's 3. But notice how there's a negative here, right? In all our previous cases, the middle number was always positive. Well, all the middle number does here is that instead of writing 2x plus 3 as my factor, I'll write 2x minus 3, right? And I'll put a squared symbol, because that's how I factor perfect squares, right? And that's all there is to it. And you can always do a quick check of the square root of a times the square root of c times 2. So in this case, has to equal b. So in this case, the square root of a, so what's a? 4. What's the square root of c? So c is my constant, that's 3, times 2, must equal b. So what's b? In this case, take the absolute value of the b, so just 12. Don't worry about the negative here. So 2 times 3 is 6. 6 times 2 is 12. So it works perfectly. So this is the factored form of this equation right here. First we took our common factor, then we used our perfect square trinomial technique I showed you in this video. Again, I know I went fast, but it shouldn't be too difficult to pick up. Your first term, your x squared term, has to be a perfect square, right? So 4x squared was a perfect square. And your c term, your constant, needs to be a perfect square as well. So 9 is a perfect square. So your factors should be the square root of the first one, so square root of your 4x squared, or the x squared term, so that was 2x, and the square root of the constant. That's what goes in here. And the sign in here is determined by the sign in the middle. If the sign in the middle was a positive, I put a positive here. If the sign in the middle was negative, I put a negative. Easy. Put the brackets, write the squared. All there is to it. Again, this only works if your x squared term is a perfect square and your c is a perfect square. And you also have to meet this condition of the square root of a, so 4 here, times the square root of c, 9 here, multiplied by 2 must equal b, which is 12 in this case. So if all of this works out, all of these conditions are met, you can go ahead and use the easy factoring technique of just finding the square root of that and the square root of this and then putting a squared there, filling the binomial. Again, hopefully that helps and you know how to factor perfect square trinomials faster now. And again, you can always use this multiplying the sky technique and go ahead and do it that way. If you want, you can watch the other videos. I explain what that is if you're just jumping in now. So hopefully this helps, and I'll have more quadratics videos coming out to help you guys out in that, and I'll post some grade 7 and 8 material when I get the chance to do that as well. So hopefully these are helping in some way, and hopefully you keep watching to get some more help here. Thank you.